You think the space between galaxies is empty. It is not. And what is actually out there is stranger than anything inside a galaxy. We are talking about structures so large that our entire Milky Way is just a grain of dust by comparison. Forces that have been building for longer than Earth has existed. Things that have no name yet, because we only found them last year. And the craziest part is that we ourselves are inside one of them right now, and nobody told us. Let us start with something that will immediately change how you see the night sky. Right now, above your head, there is a structure. You cannot see it. No telescope on Earth can image it directly. But it is there, stretching across hundreds of millions of light years in every direction. Astronomers call it the cosmic web. It is a vast three-dimensional network of filaments, like the threads of a spider web, except each thread is made of millions of galaxies and dark matter and superheated gas. And between those threads are voids, enormous empty bubbles where almost nothing exists. Our own Milky Way sits inside one of those filaments. We are part of the web. And the web itself is the largest known structure in the universe. But here is the part that nobody talks about. The filaments are not just sitting there. They are moving. Gas is flowing along them like water along the roots of a tree. And that gas is building galaxies, right now, all around us. Between the galaxies, space is not empty. It is filled with gas. Incredibly thin, incredibly hot gas. We are talking temperatures between 1 million and 10 million degrees Celsius. This gas is called the intergalactic medium, and it contains more ordinary matter than all the stars and galaxies in the universe combined. More. Combined. Every star you have ever seen, every galaxy and every image from Hubble and Webb, all of that is a minority. The majority of ordinary matter in the universe is invisible to the naked eye, floating in the space between galaxies as a nearly perfect vacuum of plasma, so hot it only glows in X-rays. And we missed it for most of human history because we were only looking at visible light. The universe hid most of itself from us until we built the right kind of eyes to see it. In 2000, astronomers pointed a telescope at a patch of deep space and found something impossible. A glowing cloud of hydrogen gas, bigger than most galaxies, sitting in the void between them. No galaxy inside it, no obvious power source, just this enormous, shapeless thing radiating as much energy as 100 billion suns. They called it a Lyman alpha blob, and they had no explanation for it. Over 2 decades later, they still do not have a complete one. The largest confirmed examples stretch 400,000 light-years across. That is several times larger than our entire Milky Way. And they are just floating there, in the dark between galaxies, glowing. We have found dozens of them now. Each one is a mystery. Each one is telling us that the universe between the galaxies has processes we do not understand, events that follow rules we have not written yet. Here is the part that should genuinely unsettle you. In 2013, astronomers mapped the distribution of galaxies in our cosmic neighborhood and found something unexpected. We are in a hole, a vast underdense region of the universe called the KBC void, named after the 3 researchers who characterized it. It stretches roughly 2 billion light-years in diameter. Our entire local group of galaxies, our Milky Way, Andromeda, all the small galaxies around them, sits near the center of this enormous emptiness. The density of matter inside the KBC void is about 20% lower than the cosmic average. We are in a cosmic bubble, surrounded by a shell of denser galaxy clusters and filaments on the outside. And this matters because it may be part of the reason the universe appears to expand at different rates depending on which direction you look. The Hubble tension. The most argued about problem in cosmology right now. Our weird address in the universe might be a clue. Something is firing bullets at us from intergalactic space. We do not know what. Cosmic rays are particles, mostly protons, traveling at velocities so close to the speed of light that they carry energies that dwarf anything produced by our most powerful particle accelerators. The most energetic one ever detected, called the "oh my God" particle, carried the kinetic energy of a baseball thrown at around 90 kilometers per hour. In a single subatomic particle, traveling at 99.9999999999999999999999999999999999999999999999999999999999999999999999999999999 the speed of light. It arrived in 1991, and we still do not fully know where it came from. The problem is that particles at these energies cannot travel more than about 160 million light-years before being degraded by interactions with the cosmic microwave background radiation. So they must originate relatively nearby on cosmic scales. We have narrowed it down. We have traced some of them back to general directions, but the sources remain uncertain. Something in the nearby universe is an accelerator more powerful than anything in physics, and we have not found it yet. Between the galaxies, threading through the cosmic web, there is something we cannot see at all. Dark matter. It makes up about 27% of the total content of the universe. It has mass. It has gravity. It bends light. It determines where galaxies form and how the cosmic web is structured. And we have never directly detected a single dark matter particle. We know it exists because the math does not work without it. Galaxies rotate too fast. Light bends too much around clusters. Structures form too quickly in the early universe. Something is there, exerting gravitational influence on everything around it, and it is everywhere in intergalactic space. The filaments of the cosmic web are not made of gas. They are made of dark matter, with gas and galaxies clinging to the outside like frost on a wire. The dark matter came first. It was the scaffolding, and we are built on top of it, without knowing what it is. In 2007, we found a signal. It came from intergalactic space, a burst of radio waves lasting only a few milliseconds. By the time it arrived at our telescopes, it had traveled through billions of light-years of intergalactic medium, and the dispersal of that signal across different frequencies told us exactly how much material it had passed through. This was the first fast radio burst. Since then, we have found thousands of them. They arrive from all directions. Each one carries more energy than the sun emits in 3 days. Each one lasts less than the blink of an eye. Most of them arrive once and never repeat. A few repeat, unpredictably. We now believe the most common source is magnetars, neutron stars with extreme magnetic fields. But the details remain open. And every time a fast radio burst arrives from 3 billion light-years away, it carries a fingerprint of everything it passed through. The intergalactic medium itself. These signals are becoming a tool. We are using them to map the matter between galaxies that we otherwise cannot see. The most energetic events in the universe since the Big Bang are not supernovae. They are not gamma-ray bursts. They are galaxy cluster collisions. When two galaxy clusters collide, trillions of solar masses of matter interact over timescales of billions of years. The gas in each cluster, which makes up far more mass than all the stars, collides and heats to hundreds of millions of degrees. It screams in X-rays. The dark matter passes straight through itself because dark matter does not interact with normal matter or with other dark matter through anything except gravity. So the dark matter halos of two colliding clusters pass through each other, while the gas piles up in between. We have seen this happen. The bullet cluster is the most famous example. Two clusters that collided about 150 million years ago. The image shows the gas in the middle and the dark matter mapped by gravitational lensing out to the sides. It is the single most direct evidence we have that dark matter is real. It is also a picture of violence on a scale that makes any other cosmic event look trivial. In 1981, astronomers completed a survey of galaxies in the constellation Boötes and found a region of space approximately 330 million light-years across, containing almost no galaxies at all. They called it the Boötes Void. If our Milky Way were at the center of the Boötes Void, we would not have known that other galaxies existed until the 1960s. The void is so empty that astronomers initially wondered if it was real. It was. Only a handful of galaxies have been found inside it, and astronomers believe those might be interlopers, galaxies that wandered in from the edges. The Boötes Void is one of the largest known voids in the universe. What created it is still uncertain. The standard answer is that it formed from the same gravitational processes that created the cosmic web. Matter flowing outward along dark matter filaments, draining the interior regions. But the Boötes Void is unusually empty even by those standards. Some researchers have noted that it is suspiciously round and remarkably devoid. The universe does not owe us an explanation. But standing inside a bubble that large, looking outward at the thin shell of galaxies on its surface, it becomes impossible to avoid feeling very small. Between the galaxies there are stars. Not in any galaxy, just floating in the intergalactic void, alone. They are called intracluster stars, or intergalactic stars, and they are more common than anyone expected. Astronomers estimate that in large galaxy clusters, between 10 and 50% of all stars are not inside any galaxy. They were stripped out by tidal forces during galaxy collisions. Their home galaxy was torn apart, and they were left behind, drifting in the dark with no galaxy around them and no nearby stars for company. The nearest star to one of these intergalactic wanderers might be hundreds of thousands of light-years away. Any planet orbiting such a star would have a night sky almost entirely dark. No Milky Way band overhead. No neighboring stars visible to the naked eye. Just an ocean of darkness in every direction, with the faint smudges of distant galaxy clusters at the very limit of visibility. A planet around an intergalactic star would be perhaps the most isolated place in the observable universe, and there are billions of such stars. In 2004, astronomers studying the cosmic microwave background, the ancient light from the Big Bang itself, found something that should not be there. A cold spot. A region of the sky roughly 5 degrees across that is significantly colder than the surrounding background. It is not a small anomaly. It is statistically significant enough that it requires an explanation. Several have been proposed. A supervoid, an enormous underdense region between us and the background that drains energy from photons as they pass through it. A collision with a parallel universe, a bubble from another region of the multiverse that left an imprint on our CMB. A statistical fluke, the least exciting possibility. None of these have been confirmed. None have been ruled out. The cold spot remains one of the most unexplained features of the observable universe, sitting quietly in the southern sky in the constellation Eridanus, refusing to give up its secret. Here is how this ends. Not with an explosion, not with a dramatic event you can watch in real time, but slowly, inevitably, with the universe emptying itself out. Dark energy is pushing the galaxies apart. Right now, most galaxies are already too far away for their light to ever reach us. The observable universe is a shrinking bubble. Over the next hundreds of billions of years, The galaxies beyond our local group will recede so fast that their light will never reach us, redshifted into invisibility. The intergalactic space will grow, the voids will grow, the filaments will thin. Eventually, a civilization in the far future looking out at the universe will see almost nothing. A handful of nearby galaxies merged into one giant elliptical. And beyond that, darkness. Not because the universe ended, but because the universe got too big and the light could no longer cross the distance. The space between galaxies is not empty, but it is getting emptier. And one day, from the perspective of anyone still watching, it will be indistinguishable from nothing.